Just redo that.
Yeah, so let's start with number three. So here's number three. And also save the I'll do a screenshot so you have also the worked out problem as well. So y equals 2 over x squared. And can you see my screen just fine?
Mhm.
Minus 3x plus 2. Okay. So first thing you want to do is factor as much as you can, right?
Mhm.
So the top is the top. It's just 2 is 2. For the bottom, how do you factor the bottom?
It'll be -2 and -1.
Perfect. Good. Then there's going to be usually a few things you want to find. The BA, the
There's no
HA.
hole.
Yeah, we'll look for holes, we'll look for x-intercepts,
And y-intercept.
y-intercept,
For BA,
and we'll also want to do a table slash sign chart. Do you know what a sign chart is?
remind me.
So yeah, you do a number line and you see where y is positive and negative in various intervals.
I think so.
Okay, we'll do that. So the VA is when the bottom equals 0, right? That's easy. What makes the bottom 0 here?
It'll be 2 and 1.
Right, and you write as equation x equals 2, x equals 1. Okay, good. Now if things cross off, then it's a hole. And then you plug in that x value into
By the way, there
the
is
simplified
no
form.
x-intercept.
Right, and there's no holes either.
Mhm.
Exactly. The y-intercept will be 1, so I'll write as an ordered pair. The HA is y equals 0. And there's three cases. The case when the bottom has a higher exponent and the top has a higher exponent, the top and bottom are the same. When the bottom's higher, exponent's 0. Because when x gets really big,
Or if they equal 0. Oh no.
they equal each, if the
If
degrees,
they equal, and then it goes to
it's
the
a ratio,
exponent.
it's a ratio of the leading coefficients.
Mhm.
And if the top is a higher degree, there's no horizontal asymptote. Then let's say you have a slant asymptote, but we'll cross that bridge. Actually, it looks like we don't have to deal with that. So it looks like your teacher kept it simple. Okay. Then I'll do a sign chart. And so,
Yeah, we didn't do
okay, you can make a table if you want. But sign chart's kind of nice because like what I'll do is I'll test value. So what I do when I make the sign chart, I focus on the vertical asymptote and the x-intercepts. Because that's where you see a change in y, a change in the sign of y, where y goes from positive to negative or vice versa.
that.
It happens at the asymptotes, vertical asymptotes, and the x-intercepts. So if I plug 3 in, obviously the y is positive. If I plug 1.5 in, that becomes negative, but that's positive, so you have a negative.
Can you help me graph this before we go further?
Well, no, we need to do this to do the graph.
Okay.
So I know the graph is going to be positive when x is bigger than 2, because if I plug in values bigger than 2, x minus 2 is positive, x minus 1 is positive. If I plug in something between 1 and 2, like say 1.5, negative, positive. If I plug in something less than 1, negative and negative, two negatives make it a positive, right? So now, one, two. And then it's going to be negative, so it'll be kind of like a problem, right?
Um,
And y-intercept is what? 1.
in my in my class,
There's a graph.
in my class, he said that we had to do something because that if we do that, that's just guessing. We need to like test it.
I did test it. I mean, you could plug in points if you want to be more
Well,
precise. You
the way that
can.
he does it is that
Hmm?
I don't know exactly, but
The big table.
he shows it like what if this was like very big and very small.
Yeah. No, end behavior. We already did that for horizontal asymptotes. That's end behavior. We already did that.
I
That
still don't
that that, that
understand.
no, we found the horizontal asymptote because the bottom had a higher degree. So it's y equals 0. We did do that. What's your
I'm not
question?
talking about that. Like the way he did it was like here we had why he did this.
Give it a table.
Yeah, and then
Okay,
he would plug in
sure,
like a
numbers.
1,000.
That's the same thing. That's the same exact thing. That's exactly what we did here. We did the same exact thing. Because you imagine what happens to y when x gets really big. Y gets closer to 0. I mean, there's other ways you could prove it. I don't know what I mean, sure, you could plug in 1,000 and see what happens. It's going to be very small. But
Okay,
we did the same exact thing.
okay. When you're doing it, when you get your answer, how can you tell if it's any of these? How can you tell if that's not that or the
Okay,
other
because
way?
I had a horizontal axis at y equals 0, I have to go towards 0 on each side. That's why. I have to go towards 0 here, which I just did, and I go towards 0, which I just did. That's exactly what I did. That's it. There's really nothing else to it. And it's incredibly replicable. We would do this over and over and over again this way. We will still get the same result. I mean, if you want to make a table for the other points, you can. If you want, like you can plug in 3 or 1.5 or 0.5 or -1, you can. But this is a more efficient way of doing it, and it's accurate. There's nothing inaccurate about this. Another way you could have done it too, I suppose, is you can multiply top and bottom by 1/x². Because then you get 2/x². You get 1 minus 3/x plus 2/x². So this just goes away, it becomes 0, right? And that becomes 0, that becomes 0. So 0/1 minus 0 minus 0 gets you 0. So I mean, you could do that too, I guess, if you want to do that. But I don't think you guys have done that. That's usually I do that for more of my honors classes. I approach or calculus.
We didn't
That's
do
more of a
that.
that's more of a calculus approach.
Uh-huh.
Really, it's just, but your teacher's correct. I totally agree with the teacher. Yes. What does y do when x gets really big?
I'm so confused
Okay,
right now.
okay. So your teacher did this, right?
Yes,
Yeah, and you plug in what happens? You get 2 over a big number, right? And what's 2 over a big
yes.
number? It's 0. It's close to 0. And that's exactly what I did over here for the HA. I did it exactly. And see the graph goes towards 0 for y on the right side and goes towards 0 on the left side.
Okay.
I'm doing the exact same thing as your teacher.
What if it was
-1,000? Same thing.
sure?
Same thing.
What if it was bigger than 2?
Well, then it's going to be some random number. Sure, let's plug 3 in. If I plug 3 in, I get 2 over 2, which is 1. So yeah, 3 comma 1. There you go.
Okay.
Great. You got it. Let's try another one. I think when we do more of these, this will sink in a little better.
Okay. Yeah, number 4.
Let's see number 4. Okay, great. All right. What's the equation? Y equals save that. So now let's try our VA, our HA, our holes, our x-intercept, our y-intercept. Our VA is x equals -2. Our x-intercept is 2 comma 0. Our y-intercept 0 comma -1. Our h is y equals 1. And the whole,
Is X plus 2.
oh,
Well,
there is no VA. Yikes. Sorry. Let me,
the whole is,
actually,
well, the X is, the whole is,
the same as the vertical asymptote.
So then we don't have
You
one.
don't have a hole, yeah, because you can't still can't plug -2 in to the original. Yeah, so you don't have a hole, right? It's a vertical asymptote instead. That's interesting. That's a very interesting graph. Okay, all right. Well, that's what it is. Yeah, because you can't plug in -2. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So then, if you're more comfortable, if it makes you more comfortable, let's plug in some points in. Let's plug in like say 3,
Mm-hmm.
and let's plug in maybe like 10, and let's plug in maybe like say -1, and maybe -2, and maybe -10.
Okay. So if we plug in three, it'll be,
1/5.
I thought the way we did it was with the base.
No, 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 no. You plug in the simplified forms easier,
Okay.
much easier. You get the same thing either way.
Okay, so yeah, you get one, well, yeah, you
Over
get
5.
1/5.
Then here you get 8/12, which is 2/3. And then we get -3/1, so -3. Next you get -4/2, so it's 2. -10 you get -12/8, so it's 3/2.
So,
What question?
so
Hmm?
the, how do you connect this to where it is on the graph?
Yeah, they plot the points, right?
Mm-hmm.
So plot the points. So I graph 10 2/3, 3 1/5 over here, -1, -3 is right here. So the curve does this, right?
Okay.
Because the asymptotes guide the graph, right? Um, and then I graph 3 1/5. Sorry, -2, -2. Wait, I went to say -3. Yikes. -3. That's -5. Geez, sorry. What am I thinking? By putting -3, -3,5, it gets way higher. -10 3/2. There you go.
Okay. So this is just to add like a guide.
Yeah,
Okay.
yeah, 100%.
Now
Yeah,
this whole unit,
yeah,
I've
100%.
been just getting information, but it's not sticking with me.
Yeah.
I'm trying to keep it in
Did
the
this problem feel a little better than the previous one?
yes.
Okay, let's try another one. Let's do the next one here. Y equals -3x -6 over x squared -2x -8. Okay, so you factor out -3 from the top and factor x -4, x plus 2. Okay, now we definitely get a hole.
Yeah, we have a whole, and then
Good.
we there is no horizontal asymptote. Asymptote.
Okay, no, so y
But
equals
wait,
0.
yeah,
Yeah, so your VA,
would be 4.
your HA is y equals 0. Your holes, putting -2 in, so it's 1/2. Your x-intercept is none. The y-intercept is 3/4,
Wait, why is the x-intercept none?
because if you look at the simplified form, you can't make the top 0. The top is -3. Right? The top can never be 0. You just said it earlier for this
Why?
one, right?
Oh,
Yeah, yeah.
yeah. Sorry.
Yeah, no, sure, you could plug into here, but remember, it canceled with the factor down below.
Mm-hmm.
So it was gonna be 0 over 0 anyway. If you plug in, if you try solving this, sure, you get -2, but you can't play -2 in the bottom anyway. That'd be a problem. And then we'll do so let's graph this. Points. So we will need to make a table. Let me plug in 1. Let me plug in 3. So I'm plugging numbers close by, right?
Yeah, so
I'll plug in 5. I'll plug in 10. I'll plug in -1.
if
And I'll
you
plug in -10. Okay.
look at 1, you'll get
Uh,
-1.
+1.
Oh, yeah. Yeah, +1.
Plug in 3. I also get +1. Is that right? Wait, does that make sense? Hold on.
No, you get +3 because you get.
You're right.
Yeah.
Wait. Something seems fishy here, but hold on.
Wait, no,
No, if I plug in
you
3,
don't. Wait, no, you do. You
-3.
do.
But then if I plug in 1, wait, something seems off here. If I plug in 1, hold on a sec. What the heck are we doing wrong here?
If you plug in 1 -4.
Oh, I put. Okay, I did this wrong. That's why. There's a hole at -2.5. I put first. I did +2. So this is why we do all these things, because we need these stop gaps in place, right? This is why we spend the time doing this, because when things seem off, it forces to double check our work. Okay, I feel better now. If I plug in 5, I get -3. If I plug in 10, I get -0.5. Plug in -1, I get 3/5. Plug in -10, I get 3/14. Right.
One, not the only curve I could see happening is there.
So I know I have a curve looks like this, right?
Oh, yeah, that too.
Then here,
Yeah, that. The line you said.
oh, it's -2.5. Oh my goodness. Hey. Okay, sorry. See, this is why we have all these things in place, because I realized I plotted -2.5 over here and that right there. There you go.
How are you?
Good yourself. Yeah. And there you go.
Yeah, I think I'm understanding now.
Yeah.
Okay.
So yeah. Yeah. And again, you just have to be careful, because notice I plot some points in the negative. region, like I accidentally did -10, -3/14, or I did, I accidentally did the whole like a -2, -0.5. I did 2 -0.5 initially, so I don't know what's wrong with the holes, why I messed up that one up, but yeah, but there you go. Yep.
I'm
Okay.
gonna try and do.
And hold on, let's see. Do you want a domain or range? No, not really, because those are too hard to do.
Yeah, no.
Domain's not too bad, but anyway. Okay, so now go and try 6 on your own.
Yeah,
Yeah.
I'm gonna try to
Yeah.
do this one. By the way, what is that symbol code?
Lambda. It's a Greek alphabet.
The quiz.
Mhm.
I can remember what to do for them. I just don't know which one to use it on.
Got it. So you have 5 over x minus 4 equals 3 over x plus 8. So you cross multiply.
Yeah.
And that's that. So you just cross multiply.
Mhm.
You do here exactly one fraction on each side.
So
Mhm.
you cross multiply if it's one fraction each side
Yes.
for any of them.
Yes.
Okay.
Yeah, you're gonna cross
Same
multiply
thing.
again here. Yes. Okay, now here you won't cross multiply. So you could do a couple ways. One way you could do is like this. So you can make that 2 over 1. And then you can multiply both sides by the LCD of everything, which is 3x. But you only multiply to the numerator. So you get 6x over 1. You get 6x over 3. You get 8. Wait. Yeah, no, we're fine. Wait, hold on, I'm losing my mind. Hold on. And you get 24x over 3x. So that's 6x minus
Which would
2x.
still make it 8.
So like, yeah, so then 4x equals 8. X is 2.
Okay.
So that makes the problem more streamlined. But again, whole numbers, make them fractions, force the issue, make it over 1, because any whole number is a fraction. So over 1.
Okay.
We don't do it because it's kind of redundant. Then you find the LCD, not just for the left side, not just for the right side, but the combination of left side and right side. The LCD is the least common denominator. So you got to pick a multiple of all these, a multiple of 1, 3, and 3x. Of course, it'll be 3x, right? So then what you do is you multiply the numerators by that, and then you reduce afterwards. Now, another way you could have done it, if you so desire, you could have done this. Simplify each side. So like that's 2 over 1. So make that 6 over 3 minus 2 over 3, which is 4 over 3, right? Then you can cross multiply. Because you can only cross multiply when you have one fraction, but you can force the issue by making that one fraction by doing the LCD. But in this case, I got to multiply top and bottom of 2 over 1 by 3 over 3 to make that happen.
Okay.
So yeah.
Yeah, they did it differently. They did it this way.
They did it the way I did it the first way. They did the first way.
Well, for this one, they replace it. They don't change it. Like here, they.
No, they don't replace it. They're canceling out the 2 x's. They're canceling things out.
Oh, okay.
They did it. It's pretty similar. They just did a little slight twist at the end, but it's still the same thing. But I think if you like the way I did it, that's fine. Let's try another one. Yeah. So you have 6.
Which way would we do this one?
So yeah, you have some options. You could get rid of like make that 6 over 1, right? And then you multiply everything by x plus 1. Because that's the LCD for everything, right? Because you have 1, x plus 1, x plus 1. So it happens that becomes negative parentheses x plus 1 over x plus 1. That comes 6 parentheses x plus 1 over 1. And that comes plus x parentheses x plus 1 over x plus 1. and those cancel. Those cancel becomes -1. So you have 6x plus 6 plus x equals -1. 7x equals -7. X equals -1.
Where did you get the? Oh wait, no, never mind, never mind. Yeah, yeah, I see it. And so is this its own thing separate from the other two we did?
No, same thing.
Okay.
Same thing. Now, another way we could do it too is that when you see two fractions that already have the same denominator, let's combine them. Let's move that left side to the right side. So now it becomes one fraction like that. Now you can cross multiply. There you go.
How do you cross multiply if it's equal? I thought you couldn't do
Yeah, you
that.
can, of course you can, because 6 is a fraction. Any whole number could be a fraction.
But
Multiply x plus 1 is 6 and 1 to -1 minus x.
okay.
100% can do that. 100%. Any whole number is a fraction. This is why people struggle with fractions. They don't realize they can do that. Once you realize you can do that, then yeah, just
Yeah,
treat
I
it
was
like any
talking about
fraction.
the equal sign. I thought you
What
couldn't
about it?
I thought you couldn't do it when it's an equal sign.
No, we do cross multiply when it's equals.
Okay.
No, we do. 100% we do.
Okay.
Just go back to the you don't cross multiply when there's times, you cross cancel. If you have same factors, you can do that. But no, you absolutely cross multiply when there's equals. Absolutely, 100%. I don't know how else you would do it. Now here you're just adding two fractions, right? So 5x plus 2. So the LCD here, and usually you can't combine them, so you kind of just leave it like this. I mean, sorry, you can't simplify it. Yeah.
Okay. And then
Yeah, that's even easier. So I'm not going to rewrite the whole thing, but I'll start factoring it. This is
or you could just get a similar, make up a similar one.
no, we should do this one. This is Delta Math level 3
I screenshot it.
multiply / divide. Okay, good. So it's x plus 1, x plus 5. X plus 3, x plus 5. X plus 1, x plus 2. X plus 1, x plus 3. X minus 5, or x plus 1, x minus 5. Factor on x, maybe x minus 5x plus 2. Boom, 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 boom. It's lovely that happens. So you have x times x minus 5 squared over x plus 3 squared. Bingo, we got it.
Okay.
We're good? Yeah.
Yeah. Um, can you meet this Friday?
Can't this, well, let me think. It would have to be on Zoom, I think. Yeah, Yeah, I do need to get over to Carter's
Well,
house. Let me stop.
Can you meet in person anytime this week
I can't look at one sec. It's
or the
really-
weekend?